This one's so much fun. I love this one. Check this out. This is called combinations which are equivalent. Remember what equivalent means? Equals. So we're looking for combinations that are equal to each other. Let's get an example. I'll show you what I mean. It says, in a fundraising committee is to be formed from a group of 8 students. So you got 8 students you can choose from. Why is this choose? Because you're not assigning duties to these 8 students. You're not saying you're going to be president, you're going to be vice president, you're going to be treasurer. If you did that, then that would be a pick. It wouldn't be a choose. Okay, so let's choose the right ones here. The committee is to consist of 3 students. So we got 8 students. We're going to choose 3 from that. Now, what I want to do is I want to look at this in terms of my calculator and see what this gives us. So I'm going to go 8 second alpha. There it is. I'm going to go 8 here, and I'm going to pick 3, or sorry, choose 3. Boom! I got a number of 56. All right. That equals to 56. Great. Now, read this one. The committee is now to be consisting of 5 students. Oh, okay. So I'm going to go 8. I'm going to choose 5 kids out of that. Okay, so what does this mean? All right, well, let's go to the thing, and here we go. Alpha, blah, 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 F2, there it is. There's that guy there. I'm going to choose 5 students, and I'm going to get, what? I get the same number. I get the same number. I get 56 again. Well, why is that? Because think about this. Whether you're choosing 8 students and ignoring 5, or choosing 5 students and ignoring 3, your combination here is going to be the same, same, same. Now, why? Look at how this and this are complements of each other. 3 and 5 add up to 8. That's the rule. Isn't that wild? I'll even prove it to you using your formula and factorial notation. It says right here, prove that 8 choose 3 and 8 choose 5 are the same thing. Remember the formula from the textbook or from your formula sheet. Check this out. Let me show you, right? The formula was 8 choose 3 means 8 factorial over, remember, these two have to be subtracted now, 8 minus 3 factorial over this guy, 3 factorial. Simplify this. 8 factorial, 8 minus 3 is 5 factorial, 3 factorial. Okay, we're good. Now, watch what happens when I do this one now. 8 choose 5. And 8 choose 5, this is again 8 factorial over, guess what? Now it's 8 minus 5 factorial, 5 factorial. But watch what happens when we clean this up. 8 minus 5 is 3 factorial, and this is 5 factorial, which is exactly the same as that. They, in fact, give you exactly the same numbers. So what do you have to do when you want to do something like this? Well, when you do something like this, just make sure that the combination that you use, this one and this one, add up to this original number. That's all you got to do. Case in point, check this out. Because in E, it says, give me another 2 examples of this. Give me another 2 examples of this. Well, it's really, really easy. I'm going to choose 10, choose 4. Can you give me the complement to that? Well, of course. What is added to 4 to give me 10? This would be 10, choose 6. 4 and 6 add up to 10. Let's prove that. Let's prove that. 10 choose 4, 10 choose 6 better be the same thing. Okay, so 10 alpha F2 choose 4 gives me 210. But check this out. 10 alpha choose, right? 6. Watch this. This will freak you out. 210. They're both the same numbers. They're identical to each other because of the formula, because of the relationship in the formula. Now, here's something that's cool. What is this used for? When we get to something called Pascal's triangle, this will become incredibly valuable. And I'll show you what that means as we go. So the general rule is n choose r is the same as n choose n minus r. Or we can do it in this alternate notation that we have here. Okay, but let's show this algebraically. let's prove that this actually works out algebraically. So we want this to be equivalent to this. So you know what? Let's just put down exactly what n choose r is. We all know that this is n factorial over, well, these two have to be subtracted, so it'd be n minus r factorial over this guy factorial. Okay, fine. That's what it works out to be. Let's make it look like more of a factorial there. There we go. Okay. Now, let's do this guy. Let's prove algebraically that they are the same. So we have n choose n minus r. Okay, so on top again is our n factorial. So these guys work out, check, perfect. Now, we got to subtract these two, right? Just like we subtracted these two, we got to subtract those two. So this is going to be n subtract n minus r. Oh my God, yeah. And that's all factorial, okay? Over, oh, okay, there's that n minus r factorial stuff. Now, let's just clean this up a little bit. Okay, I can do that. Well, a little too far. Here we go. So on top, I still have my n factorial. That's fine. That works. On the bottom, look at this. Don't you distribute the negative? So wouldn't this be n minus n plus r? Oh, make that look like an n. So guess what? The n's cancel, leaving you r factorial on the bottom and n minus r factorial, which, look, is identical to hello right here. So I just proved this algebraically for you. Now, what is this all about? I'm going to put a pause on this guy until we get to Pascal's triangle, which is coming up in about 2 or 3 podcasts. So hang tough.